Hey friends, today I'm going to show you how to make a GitHub Skyline using your GitHub contributions. In a previous video, we actually scraped this GitHub data ourselves and created an API using Svelte. But before I get to that, first what are we going to use? We're going to use Threlte, which is a 3D framework for Svelte, which is a wrapper around Three.js. Of course, this video isn't going to be a tutorial on how to specifically use this too, and is more to inspire you and show you that these things aren't that intimidating, because I'm not really a Three.js professional or 3D, I know some basics, but I can get things done, right? And you're going to see how simple that is, especially thanks to Threlte. So we're going to use the API which we made ourselves. You can watch that video if you want to learn how to use scraping in Svelte to make something like that yourself. And here I hosted it, this link, so we can go to this link. And now we're going to use this API. So you can copy this link over, and of course I should type in the user. So you can type in your username, your year. And if you notice one thing from the video where we ended off, I did the homework, so we can also type in the current year. And how I've done it? Well, it's really simple. So as I showed you in the last video, we set the header, so I hosted this on Vercel, which is super easy peasy. If you're going to use this in a real project, I recommend you host it yourself, because I can't guarantee this API is always going to be up for whatever reason, right? But it's really simple, it takes 1 minute to host it on Vercel, slap these cache headers on, right? Boom, that's it, done. As you can see, I've also done the homework here. So I also made it possible that you can type in the current year. So we check, hey, if this is the current year, then we're going to change it in this format. You just need to pass year, month, and the date, and that's basically it. I'm not going to bore you with the details if you're not interested in this, but just interested in the Threlte aspect. Alright, so I'm excited to get started. Alright, so let's get started. The first thing you see is this gorgeous Threlte site, and you can already see what Threlte is capable of using Three.js, and you can spice up your boring portfolio or whatever else you want. So you can see Threlte is a 3D framework for the web. It's built on top of Svelte and Three.js. And you have some testimonials here, so even Rich Carey says, indeed, Threlte is where it's at. So of course, it's a great framework. So let's look at the documentation and let's see what this is about. So as I said, this isn't going to be a tutorial on how to specifically use every feature of Threlte, right? But I actually want you to understand what this is about. So basically, this is a wrapper around Three.js, and it extends really everything that Three.js has in the documentation, and it really makes it intuitive. The prerequisite for using Threlte is knowing some basic Three.js, but you can get by. But the best part is that you can just look up a Three.js example, and then you can translate it to Threlte easily. So let's see how that works. So here we define a scene. We're going to look at that when you initialize the project. What I want to show you is how simple this is. So as you can see this code here, I'm going to zoom in so you see it better. So you can see we just import T, which is where everything gets extended from Three.js. So if you look at Three.js, and if you look at Object 3D, for example, here is where everything gets extended. So this is going to extend the Three.js class. You can see here it has a mesh, geometry, and a basic material. And let's look at the equivalent Three.js code. So we can see here it looks the same, right? Almost you can easily translate this, how great the API is of Threlte, right? So you have geometry, material, mesh, and then you can just do this. And this is the equivalent in Threlte, right? And you get the cube, and how beautiful is that? And this is another thing you have to keep in mind. So basically when you look up things, what methods and property can I use on objects, really this isn't going to be documented in Threlte, because Threlte would then just copy the Three.js documentation. So you just look at the Three.js documentation. So everything extends this base class Object 3D. So for example, you want to know what you can use on everything. So there's going to be a position. And then you can see, okay, position, where is it? It's somewhere here. Okay, you see here, position is vector free. And vector free just means it has three properties, X, Y, and Z. And then you just pass it the position. So you know that prop is available. And of course, you have TypeScript and great auto-completion in your editor. But another thing that's awesome about Threlte that I want to showcase is Pierce props, I think. So we can go here. Let's see, Three.js equivalent. Yeah, so for example, you have this mesh here, and you want to set scale or position on it. So you can literally set the prop on this component. So you can say position.y, and this is called a Pierce prop in Threlte. So let's see if there's a code example. Oh, here it is. So you can see here is mesh, and okay, so you're looking at an example in Three.js like this, for example. So you have mesh position y. Okay, what do you have here? You have mesh position y. Oh, how mind-blowingly beautiful that is, friends. And then you also have things like arcs. So this is what you pass to the constructor. So for example, in Three.js, I don't know why I closed the docs, because I'm a genius. Let me just go to the docs. So if you have box geometry here, and here it's like, okay, you're going to pass width, height, and depth. So you can see here is the box geometry. Okay, how do I do this in Threlte? Here is the box geometry. What do I pass into the constructor? Arcs. Boom. That's how easy it is. How awesome is that, friends? So as you can see, everything extends from this base T class. So if we go to the core, for example, core, we can go to T. So this extends this object 3D. So you can just use this. You can pass it a mesh if you want. Really, you can read this documentation forever. Alright, so let's set up a Threlte project, and it's really simple. If you go to their docs, we can go to installation. You just need to run npm create Threlte. And that's basically going to use the same SvelteKit CLI, but install packages for you, so you don't have to do it. But of course, you can manually install Threlte inside of an existing project. So we're going to use Threlte core, and then we're going to also use some extras, so we get the grid and etc. So if you want to install this in existing project, Threlte is going to spit out this CLI command for you. So really, that's really awesome. You don't have to think about anything. And if you go to the extras here, you can see here we have things like grid. So this is what you're going to use. And it has a lot of useful helpers like this. Alright, so here I'm inside of an empty project. I'm just going to open the terminal and let me just zoom in so you can see what's going on. So I'm going to use pnpm, but you can use npm, it's really not important. I'm going to say pnpm create Threlte. So give it a second. Awesome, welcome to Threlte. So I want to create inside of an existing directory. I'm going to use TypeScript, which is optional, you don't have to, but I highly recommend it because you're going to get great auto-completion. I don't really care about any of these options right now, so I'm just going to press enter. And then for the packages, you have to press spacebar to select it, so don't press enter, select spacebar. For extras, we don't really need Rapier. Theater is really awesome, I'm going to show that to you in a second, but we're not going to use this inside this project. So I'm just going to press enter, and I'm going to say no. So I want to install dependencies using pnpm. That's awesome. And while that takes its sweet time, I'm just going to show you how awesome Theater is. So the hardest part when you start out in 3D is like understanding and manipulating the objects, because it seems like you're just trying out values randomly in the dark. If you want a GUI helper, then Theater is really awesome for that. So let me just find an example. I think it was here somewhere. Oh, okay. So here's an example like that. So you can basically install this package and then you can initialize it in your project. So now you have this tree. It's like using Blender almost. How awesome it is, right? So you can select this box. We can move it around with these controls. You can change the color, whatever you want. And now you have artistic freedom to do whatever you want instead of just hard coding some values in an editor and then relying on hot reloading. And how awesome is this, friends? And let's see if this is done. Awesome. So now we can say pnpm run dev. And while that is booting up, let me just close this since I don't think we need it. And let's just keep open the docs just in case. So now we can open it here. It's going to take a second since it's the first time. And we should get some default objects here. And how beautiful is this, friends? So let's look at this code here, even though we're going to remove it. So inside of here we have some source. And really this organization isn't important. You can organize this however you want. But let's really check it out. So here inside of app, here is where we initialize the scene. And that's basically it. So here is the code itself. Let me just close this. You can see here we have a perspective camera, which is set as default. So really this code is really clean and beautiful. Here are the orbit controls. So this is what gives us this auto rotate. You can see I'm not doing anything, it's just moving around itself. You have like this helper thing float, so things can float, so you don't have to do the math yourself. We can even increase the auto rotate speed. We can set it to something like 4, and my prettier formatted file, so you can see now it's a lot faster. So now let's just remove a couple of things just so you see what's going on. I can remove the context shadow. I want to keep the box. I want to remove the torus, and I want to remove this icosahedron geometry. I can't even pronounce it. I'm a genius, by the way. Okay, so let's go. So now let's change the color. This is how simple this is. You just play around and have fun. Like, there is like really no repercussions here. This is your world to create. Alright, so I want to show you another cool thing. So this is what I was talking about. You like start first time in 3D and without someone else guiding you, like, okay, am I just going to type in random values? I really don't understand what is going on here. Like, you might not even know about the X, Y, and Z axis, right? So there are a lot of these helpers in Three.js, which Threlte also has. So one of them, we can use transform controls to at least understand what is going on. Let me show you another cool feature of Threlte. We can go to the search, you can find it here, but maybe you don't know what you want. So you can use this AI search, how do I use transform controls? And I think this is going to take a second, but it's really going to show you. Okay, so it says import the controls, going to give you code. How awesome is this, friends? Yeah, so you can just use transform controls. So here we are, transform controls. You can see here we have the same cube. So let's just look at their example. Scene, okay. So now we can see this transform controls wrap this mesh. So let's just do what they've done. So we can use transform controls. So you have this mesh here. I'm just going to remove this float also because it's distracting. Let's just delete it. And boom, just like that. We're going to complete it. And let's just close it, transform controls. Let's just make sure it's imported. So we can import it from Threlte extras, I think. Transform controls. You can always check here. Let's see. Transform controls. Yeah, it's from Threlte extras. Awesome. So now we have these transform controls. We can save it. Let's just look at our example, what's going on right here. And as you can see, it's off base because, let's see, position Y, because it has a different position. We can just remove this. So it's at the center. And this also has a different position, so we can remove this. And we don't even need this. So we just really want transform controls like this. And we can go here, and where are the orbit controls? We should orbit controls, auto rotate, enable zoom. So we can set it to true. So we can just zoom out like this. All right, so now you understand more what's going on. So let me just also remove auto rotate. So now you're inside here, and this is probably going to be the default view that you get. And of course, the axes depend in what position you are. But usually the x-axis is going to be left, right. The y-axis is going to be bottom, top. And the z-axis is going to be the depth. So it's going to come closer to you or further away from you. And that's basically the basics of 3D. Alright friends, but let's start from scratch. So I'm going to open the sidebar. I'm going to delete most of the things here. So I'm going to delete components inside the lib folder. So I'm just going to press delete. And basically we're going to create everything ourselves inside of page. Let's just delete everything. And the only thing I'm going to add here are types. So if you're not using TypeScript, you can just ignore it. So here's what I love to do inside the lib folder. I'm going to create a types TS file. So basically what I'm going to do here, I'm going to copy paste these types from the post because we really don't want to type these types, especially if someone isn't interested in TypeScript. But basically this is the shape of our API. We have this day here. It has all these properties, and then we export the type contributions, which could be an array, which has this day, or null as the value if the value is empty, right? So I'm basically going to save this, and of course you can find the post in the description. I'm going to close this, and now we can get started. Alright, so let's set up the scene. First I'm going to use this snippet, so I'm going to create a script tag. Then we're going to need canvas from Threlte, so you can say canvas at Threlte core. So this is why you need a core. And then we're going to create a scene. So I'm going to import it in advance. I'm just going to say import scene from /scene.svelte, which we're going to create in a minute. Let me just comment this out for a second. Alright, so now we need a wrapper because we need to set the max height of the canvas, otherwise you won't see it. So now we can use the canvas component. That's basically it. And now we can use the scene inside. And let's just set some default style. So you can say style. I'm going to say scene. So I'm going to say position absolute, inset 0, so you don't have to do left, right, and etc. Then let's say background color. I'm going to use HSL, 200, 10%, and 10%. Alright, so let me just comment this out quickly. So if you look at here, everything works because this is our entire canvas. If you open the developer tools, let me just zoom in so you see what's going on. If you go to the elements here, let me just go here. So you can see here is the canvas and it takes the entire width. So make sure you get this right, otherwise you won't see the canvas. Alright, so let's create a scene. So I'm just going to comment this out. And inside of routes here, we can just go to routes. You can have your component in the same place. So as I told you, it's not really important where you put these files. We can say scene svelte. So now this is going to get imported. As you can see, scene.svelte. Alright, so now first let's get the contributions data. We can say script let contribution. So remember the types we created. I'm just going to say contributions. And let's see, do I get autocomplete for this? No, that's fine. We're just going to auto import it. And we're going to initialize an empty one. So I'm going to say import type contributions from lib types. Awesome. So now we got this. And now we need to use onMount. So we're going to use client-side rendering. We could fetch this data on the server, but in this case, it really doesn't make sense to use server-side rendering, right? So we can just use onMount. Don't forget to make this method async. Awesome. So now we can say const response. We can say await fetch. And now we can pass it API, HTTPS. So it's GitHub contributions / API for cell app. And now we'll give your parameters. So give your username and the year. Alright, so now we're going to reassign contributions to response. Say response.json. And don't forget to await it. Alright, so now let's see if it works. We can say console log contributions. Let me save it. And now we can go here to the console. So let's see if I refresh. And awesome, you can see it works. So I really get this entire table from the GitHub contributions API that we scraped. And now we can do whatever we want with this data. So I'm going to add a grid, camera, lights, and then we're going to iterate over the contribution rows, and then we're going to render a cube. So you can see here we have this count. So we already know the name, month, and etc. Day, year. It has some other options like level, so we know what color it is. But yeah, we can just go here. Let me put the mount here. Let's just import the base T component. So I'm going to say import T from Threlte core. And then we're going to import some helpers. So I'm going to need center, grid, orbit controls from Threlte extras. And that's basically why we installed Threlte extras. Alright, so now let's just go here. I'm going to scroll up. So now we can use grid. We can say it should be an infinite grid. Section color, I'm going to use this color for I, for A, for B, and for A. Also don't forget this, it's a hex color. And then we're going to make the section size. As you can see, this is super easy thanks to TypeScript. Okay, so let's see, cell size, not color. We can say 20. And we can just set the fade distance to something like 400, but you can play around this. And the reason why anything isn't showing up because we really don't have a camera. So let's fix that. So we're going to go here and we're going to say, again, everything is from this T. That's not a helper, right? So T, you want what? You want a perspective camera. All right, so let's autocomplete this. So we need to make this the default camera. And now we just need to give it a position. So I can say equals, an object is going to be an array. So X, Y, and Z, 10, 100, 100, and then we're going to set the field of view to be something like 60. You can set this to whatever you want. Let's also give it orbit controls so we can orbit around the scenes. Let's see, orbit controls. Enable damping, so it's going to be smooth when it goes around. And then we can also set auto rotate. Let's save this, and now you can see since we have the camera, let me just close this. You can see now you can rotate around your scene, and now everything is set. Alright, so before we set the lights for the scene, let's just iterate over and display cubes for each day. So first I'm going to use the center component, so we center our mesh in the center. And it has this really cool option, auto center. And then again, pierce probes, how awesome is this? We can just say position Y, 100. Alright, so now let me just scoot this up so you can see what's going on. So now I have this snippet each, so I don't have to type it out. And now from our API, I can say contributions as row. We can also take the index. And now again, a nested loop inside, we can say row as day. And then we can also name it something else like J. Awesome, so since we're going to have a null value, we can say if day. So now inside of here, we can just create the mesh. So we can say T mesh like this. And let's just create all of these things. So then we're going to pass the options. And then again, T, what you want from threejs, you want box geometry, right? And then since you have the geometry, now you need a material. And there are all different sorts of materials, but we can use mesh standard material. And that's basically it. So really, if we save this, you really shouldn't see anything because you haven't set the properties. So on the mesh, we can set the position. So you can pass it an array. You can say 0x, 0y, and we want to move it on the z. So for each row is going to move it on the z. And we can do this. We can pass an arbitrary value like 12 times y. So for every row. And then we can pass the constructor to the box. So we can pass an array. X is going to be 10. we can say day count is going to be for the height, which is going to be the y, right? And then for the z, we're going to say 10. And then let's give it a color. You can give it whatever you want, but first I'm going to give it a white color. All right, so let's save and let's see what's going on. So you can see here it looks weird because we need to go here, and then we're going to add a group, which is another new thing. So we can say t group. I just do it like this. I'm going to put it up. And now for the t group, we can say position. Inside of here, we can say x0, y0, 12 times I. Oh, and also my bad. This was supposed to be the group, so I made a mistake here. So this is going to be the rows. It's going to be on the Z. So it's going to create a new row for all the days. So for the mesh position, we can go here actually, and we need to use the Y index, of course. So there's going to be on the X because we want to space the cube. So we can say 12 times J. And now we can say day count. Let me show you something first. So I'm going to do this. And awesome. We don't see really anything here because we don't really have any lights. So let's fix that. You can see some things are looking weird, but we're going to fix it. So the first thing I'm going to do is add an ambient light. So basically an ambient light lights everything equally. So this is something that you're going to use most of the time. So we can say T ambient light, and you can give it a color, whatever you want. I'm going to say intensity. And basically, if we save this, we should see at least something. So you can see it like looks okay. But we can also add directional light. So basically, it's like your sun. So we're going to have one from the left and one from the right. And so we're just going to go here. We're going to say T directional light position. So we're going to say 0, 200, 200. And then, of course, you can play with the values if you want. I'm just going to say intensity 2, and the color is going to be white. And don't forget the hash. So we're just going to mirror this, and we're going to set it negative on the other side, and everything is going to be the same. Alright, so now we're going to light our scene equally. As you can see, it already looks a lot better. As you can see, there's some weird things going on. So we can go here, and let's just go to the day count, and we can just divide it by 2. Alright, so now that fixed our issue, as you can see, everything works fine. Alright, so let's create a function getColor, which is going to take in the level and is going to return us a color based on that level. So we can go here in our script tag, and we can just say function getColor. We're going to accept the level, which is going to be a number. So let's just use a simple switch statement. So based on the level, if it's 0, we're going to return 0E, 0E, 0E. And I think I changed this so it looks better based on this background, but I got all the colors from GitHub, of course. And then you can say case 1. We can return different color. So you can say 0, 0, 4, 4, 2, A. And then let's say case 2. We're going to return 0, 0, 6, D35. Alright, so now, say case 3, we're going to return 0, 0, A, 6, 4, 8. And don't forget hash. And the last one, so we're going to have case 4. I'm going to return 0, 0, D35C. Alright, so we can go here and use this function. So here we have the color. Instead of passing the color, we can say getColor, and now we can pass day level. Let me just save this, and you should see everything looks great. So this is the exact colors we have on GitHub. How beautiful is this, friends? But we can also use local constants in Svelte. So we can go here, for example, and let's just open curly braces. So we can say const. So we can say color equal. So we can say getColor day level. And now instead of passing this, since this is the same name as the prop here, we can just do this color. Let me save this, and you should see everything works great. How beautiful is this, friends? Alright, friends, but let's make this look more interesting. So this looks kind of flat, right? Even if you have a million of these, let's just make it spread more evenly so it's more visually interesting. So how I'm going to do that, I'm going to set a base height. So you can see here, this looks bad because it's like 0, so it doesn't get any lighting. So I want the base height at least. Then I want to multiply this count value so they're more evenly spread out. And I want to set a maximum limit because it's going to look really weird if there's like 1,000 contributions or something. That is going to be like, whoop, and it's going to just look bad, right? So let's do that by creating a normalize function. I'm going to go to the script tag. I'm going to say function normalize. We're going to pass it a count, which is going to be a number, the base, which is going to be 4 by default, and we're going to pass it the offset, which is going to be 2 by default. So if you ever want to change this. All right, so let me just raise this up, and we're going to use the good old switch again. So we can just say switch true. We can say case count. So if it's 0, right, then we're going to set the base. In this case, you're going to return the base. So you can do your own experimentation, but I found that anything above 40 with this setting starts to look unwieldy. So if it's above 40, we're just going to return the count. And then for the default case, we just want to multiply the count, right? So we can say default, return, we can say count times. So now we want to take the base into consideration times the offset. So now we can go back to our loop. We can create a const variable here. We can say const y. Then we can say normalize. We can pass the count. And now wherever we have day count, we can just replace it with y. So this is going to be y. And this is going to be y. All right, let's save this and have a look at it. This already looks a lot more interesting to me. But yeah, how beautiful is this, friends? So we can try some other years. If you go here, let's just see 2001. Give it a second to fetch the API. Okay, so here this looks also interesting. And you can also pass it the current year. So if you're watching this from the future high, so you can see here it fetches everything properly. Looks great. All right, but let's return this. So the last thing I want to do is animate the height. So how can we animate the height? We can animate the height by animating the scale, actually. So we can go from 0 to 1, which is going to be the entire height of this cube. But unlike CSS, we have to interpolate the value ourselves. So how can we interpolate the value? Well, we can use the tween store from Svelte. So we can say import tweened from Svelte motion. And then I'm also going to import an easing. So I can say quad in out from Svelte easing. And that's basically it. So now we can go here inside of our script tag. I'm going to create the store const scale y. We're going to use the tween store. The initial value is going to be 0. And then we're going to set the options, 2 seconds for the duration. And then we're going to pass in quad in out, which you already imported. So basically that's it. And now we're going to use another on mount. So when the component mounts, we want to animate them. And then we can subscribe to the store. We can say scale y is 1. And now we're thinking, okay, easy peasy. Now we're going to go here to the mesh, pierce probes. How awesome is that? We can say scale y. Let's use the store, scale y. But you're going to see this doesn't work as expected. So let me save this and go here. And you can see it's really weird. It starts from the center. Also, let's just fix the camera so it really isn't annoying. Let's see where we have our camera. So let's set this to something higher, like 600. All right, so now we don't have to do that again. So now let's just refresh. As you can see, it starts from the center here. All right, so you're going to face this problem in the future. So always just wrap it in a group. And then instead of using the scale on the mesh to avoid weird behavior, you can just use the scale and slap it on the group. So now we can go here and now we can refresh everything. You can see, let's also fix the height. So we can go to here, position Y. So we can give it a value like 40. All right, now this looks a lot better. All right, so that's it, friends. If you like what you've seen, don't forget to like and subscribe, and you can support me by becoming a patron. Thank you for watching and catch you in the next one. Peace.